Okay, this is the first of 3, 4 maybe videos that we're going to have for today. This is day 3 of our area unit. Today we're going to be talking about things called composite shapes, and we're going to also work on some stuff where we're doing problems on the coordinate plane, on an XY coordinate plane. Really the idea of the day is this. We're going to work with something that's more complicated than just a trapezoid or parallelogram or whatever. We're going to put some shapes together. So, first things first, let's talk about what a composite figure is. A composite figure is something like you see here, this submarine-looking shape. I don't have a formula in my math book that says, here's the area of a submarine. What I do know, though, is if I break this submarine into parts, I notice that it's really just 4 parts that are put together, like a triangle, and a rectangle, and a semicircle, and a trapezoid. And these are all 4 shapes that I do have formulas for, right? So if I just took the area of maybe this shape, and I took the area of this shape, and the area of this shape, and the area of this shape, if I took those 4 areas, and I found them individually, then really what my goal is then just to add them together, right? Add them together, and you'll find the total area of this composite shape, okay? So, sometimes, whenever we do these problems, you're going to add areas together. So if I look at this weird shape here, you notice that I can break it up. Dotted line does that. The dotted line breaks it up into a triangle. And if you spin the page, it'll be easier to see. Really, that's a trapezoid on the bottom, right? Because I have 1 pair of parallel lines. Okay, so one of the ways to do this problem is I find the area of the triangle, I find the area of the trapezoid, I add their areas together. I also want you to know that, hey, look, there's more than one way to do this problem. If you want to even, and I'm not going to do it for this problem, okay? I'm going to do the trapezoid and the triangle like I just showed you, but what I can do is I can break this up even more and call it really 3 shapes. It's a rectangle and a couple of triangles, right? And so I would be adding 3 areas together, and that's your choice. You choose whatever makes sense to you. There's not one correct way to do it, okay? Well, let's do the triangle first. I'm going to do triangle and trapezoid. If I look at this shape, I look at the triangle over here. That's really 1/2 of a rectangle that's 30 by 16, right? If that was a full rectangle. So here's what I know. The area of that shape is 1/2 base times height. The base would be 30 in this case, and the height would be 16. And if I take 1/2 times 30 times 16, that should give me 240 square units, right? Square feet. So I've got that shape. Now let's flip it over this way. I'm going to turn it because it's easier for me to look at the trapezoid like this. So ignore the dotted line, okay? If I know the area of a trapezoid is 1/2 base 1 plus base 2 times the height. And remember, we talked about this the other day in class, that this here, really, look, I'm going to take the 2 bases and add them up and divide by 2. Really what that formula says is I'm going to take the average base times the height, right? That's the formula for a trapezoid. Well, my bases are 40 and 16. 40 plus 16 is 56. Half of 56 is 28. The average of those 2 is 28. So the area of the trapezoid is 28 times the height of the trapezoid, which is 30. And if I do 28 times 30, I get 840 square feet. So what's the total area? Well, I have 840 from the trapezoid. I have 240 from the triangle. And so I can add those 2 together. 840 plus 240 is equal to 1,080 square feet. That's the area of that composite shape. All right, let's do one more, okay? If I'm not going to add, the other way that I can do problems perhaps is to subtract. And so there are a couple of different ways that I can do this. Now, once again, here's an addition method for you, okay? I could break this up and say, look, I've got a rectangle here and a rectangle here, and so I've got all sorts of, I've got 1, 2, 3 different shapes, right? And I could add those together, but maybe it's easier to do this. What if I just looked at the rectangle as a whole? Well, the area of this rectangle would be base times height, which would be this dimension here, times 54, right? Well, so my trick then maybe is to figure out exactly what that dimension is. And so if I add up the 36 plus the 27 plus the 18, in other words, all the horizontal pieces here, 36 and 27 and 18 add up to 81 millimeters total, right? So the area of the big rectangle, without the notch taken out, okay, if that was filled in, the area of that big rectangle would be 81 times 54, which is 4,374 square units. Now, let's subtract a piece. Let's subtract this piece right here, the notch that's been cut out. Well, what's the area of that notch? That's a rectangular shape. The rectangle is 18 by 27. The area of the notch, I'm going to call it, is 18 times 27, which is 486 square units. So what I've done then is I've taken 4374, I'm going to take away 486. That means I'm going to subtract it. So if I take 4374, subtract off the 486, I end up with 3,888, and the units are millimeters, so it's square millimeters. So there's a couple of basic composite figure problems. In the next video, I'm going to just be doing the same thing, but it's going to be just a little bit more complicated.